This conference will
this
now be recorded.
This is the first of several that we will be having. And what I would really appreciate is for all of you guys to be sending through queries and giving us guidance on any aspect of rehabilitation that you feel will benefit everybody. Like I had a question yesterday and I was asked, but Inventis does equipment, so where does REMS fit in? And I said, no, it's the same equipment that is needed in hearing aid practice. So I'm going to introduce you through to Ricardo now. But just to tell you that, look, we're really pleased to have you all here. As Yvette says, we need your details. You would have read the message that I said that you've got to be here till the end. You will be gaining the 3 points. The actual webinar is accredited, plus you're receiving 3 additional points through an accredited article. And we will chat later, but I really want this ball rolling. So I'm going to introduce you to Ricardo, who heads the international segment of Inventis. Hello, Ricardo.
Hello, Jay. Welcome, everybody. Thank you. It's a big pleasure for me being here, and thanks everybody for attending. This is, I feel, the one of many successful webinars we are about to organize with AMHT, which has been for Inventis a partner, a very supportive partner for at least, I'd say, the past 5-6 years. As Jay introduced me, my name is Riccardo Rizzoli. I am a biomedical engineer. I've been working with Inventis for almost 10 years now, and I've seen this company growing and improving what we are offering, and basically even the market to become more exciting. Just a couple of words about the company, but then which I know it's not the focus. Company is an Italian one, so we are based out of Padova, which is close to Venice. Company's been founded 15 years ago, and now we offer a full line of audiological equipment, especially for the hearing aid dispensers and audiologists. We recently also acquired a French company named Synapses, who's manufacturing since 25 plus years balance equipment. So thanks to this, we expanded even more the product range we can offer. And with the occasion, I'm also here to invite you to attend the webinars we are scheduling for next week and the week after about VHIT, so device that is for balance diagnostic. It's going to be a very interesting webinar on how to perform actually the analysis of the semicircular canals. It will be held by an ENT doctor, an Italian doctor, who's also a professor at the university. And I'm sure it's going to be very interesting. So I also take this opportunity for inviting you all. The webinar is free for everybody to join, so it could be a very interesting occasion. As for today, I'll be leaving you to many experienced people in this field. 2 of them are my colleagues in Inventis, Anna and Elisa. So I'm sure you'll be you'll be discovering them and meet them throughout the presentation. The topic is a really hot one. I am sure, as I take care of many markets in the world, the real ear measurement is always something good to talk about. The popularity of this protocol is still far from being close to what should be. The importance of such a procedure is high, and the results really of those people who put that in place are wonderful. So it really need we really need to go through this procedures and get the real ear measurement, something we are confident with. So thanks again, and I leave you to the presentation and to the webinar. going through the clinical details. So once again, thanks everybody for joining, and wish you a good webinar. Bye.
Okay. Jayesh, if you want, I can start the introduction. Okay. Okay. Everybody can listen properly. I hope so. So, good morning all. My name is Anna Scala. I'm a biomedical engineer as well, and I'm a product specialist here in Inventis. Nice to meet you, and it is a real pleasure for me to have this opportunity to perform this first training with all of you. I hope you are all fine and healthy, despite this dramatic period we are going through. Anyway, looking at the bright side, this could be a pretty good moment for answering questions you come up with, fixing potential doubts you have, and sharing some ideas in order to improve even the Inventis unit's operation. Okay, so today I'm going to talk about the fitting of hearing aids with in-situ measurement and how to perform them with the REM system trumpet developed by Inventis. With great pleasure, I would like to introduce my colleague Elisa to you. This is Elisa. Elisa is a biomedical engineer, scientific referent in Inventis, as well as our quality engineer. Elisa will make a brief introduction to underline the importance of the in vivo measurement. So I leave the word to Elisa. Thank you very much, and see you in a few minutes.
Good morning, everyone. Thank you, Anna, for your kind presentation. It's a pleasure for me to be here with you and to talk about the real ear measurements performed with Inventis trumpet. So let's begin with some
Just a moment, sorry.
Okay, here we go. Perfect. Great. So let's start with the 4 major points. So we're talking about real ear measurements. We need to know what they are, so the definition, why to acquire them, which advantages they bring us, and how to acquire them. So let's start from the very first point, the definition. Real ear measurement, REM stands for real ear measurement. So there is nothing subjective about REM. Since they are measurements performed to a microphone, they are objective and repeatable, and they represent the intensity in dB SPL measurement measured at the patient ear canal. So this is the definition, quite simple actually. Second point, why should we acquire real ear measurements? We should acquire them to obtain the best configuration of the hearing aid gains, depending on the patient's need. In this way, we avoid setting the hearing aid gains based on average population curves. Using population curves could cause an error, mainly on those patients whose ear canal frequency response is very different from the average one. Consider, for instance, this example. This example is taken from a study, a quite recent study actually, which considered hearing aids of 5 different brands. So it is not a matter of brand. They were at first programmed with a proprietary fitting formula, so without REM measurements. When they were given to the patient, they gave a certain speech intelligibility index. Then the very same hearing aids were programmed on the patient with REM measurements. And you can see in the last columns that the speech intelligibility index was always improved. So this is one of the main reasons to acquire REM measurements. Third point, the advantages. We already mentioned one of them. So the patient is more satisfied. He or she can have a visual demonstration of the benefits provided by the device. So he or she not only hear better, but through an REM system, he or she can also see that his curve of hearing improves from a region where he cannot hear to a region where sounds are heard again. And through this measurement, there is a significant reduction of the number of repeated medical examinations. And you know, if a patient has to come to repeat the adjustment of the gain many times, this is a waste of time, and time is money. So with REM measurements, you avoid performing unuseful appointments with your patient. Okay. Okay, last point, how to acquire REM. Okay. So from now, I will leave you with Anna, the major points, definition, the advantages, and why you should acquire them. I hope they are clear. Now the more interesting part, how to acquire them with our Inventis trumpet. So I leave you to Anna.
Once again, and we can meet each other in 1 hour more or less. Okay, thank you, Lisa. Okay, I wanted to focus on this of our beautiful Inventis trumpet. Okay, I think that all of you can see it properly as well. Okay, I just wanted to tell you that if you come up with some question, please interrupt me whenever you need. Thank you very much. Okay, so, perfect. So, the implementation of in-situ real ear measurement, REM, gives the hearing care professional an objective, reproducible, and quantitative method to use with the fitting of the hearing instrument or amplifying devices. One of the main applications, I would say, of the REM is in the programming of a hearing aid for a child. If the hearing care professional considers only the measurement provided by the manufacturer, typically acquired with a coupler, without taking account of the measurement in situ, there would be the risk of an excessive amplification of the sound at the eardrum. In fact, you know that the ear canal volume of a pediatric patient is smaller than an adult ear canal volume. So if one presents the same intensity of a signal, the sound pressure generated in a small cavity is greater than the one generated in a cavity of larger volume. So, a real ear measurement system allows the hearing care professional to accurately measure the performance of a hearing aid directly in the patient's ear canal. The acquired measurements show the real sound pressure level, the intensity, produced by the hearing aid at the patient's eardrum, and so allows the hearing care professional to adjust the gain of the hearing aid to meet the patient's need. Okay, so the acquisition of in-situ measurements is a reliable and repeatable method for quantifying the intensity of a stimulus in dB, SPL, no HL, SPL, in the patient's ear canal at or close to the eardrum. A measurement performed directly in the ear allows one to verify the gain of the amplifying system, which may consist of the hearing aid, the ear mold, and the tubing, ear hook, and any sound filtering due to the external ear. So the aim is to check the hearing aid performance while it is worn by the patient, and to ensure that the sounds from the hearing aid output are audible and, most of all, comfortable for the patient. Okay, so how are they performed? First of all, it is necessary to have a speaker. To perform an examination, a series of stimuli with a well-known spectrum and intensity are presented to the hearing impaired individual through a loudspeaker. Furthermore, to microphones, the generated sound pressure is measured by means of two dedicated microphones. One microphone is closer to the eardrum, and it is the probe microphone. The other one is close to the pinna, and it is the reference microphone. They are both shown in the picture. So the two probe microphones, one for each ear, allows the hearing care professional to measure the signals arriving at the eardrum of the patient through a silicone tube inserted in the ear canal. The two reference microphones, one for each ear, record the signals arriving at the base of the pinna of the patient under test. And of course, it is very important to have an hearing aid. The signals acquired allow not only to evaluate the performances of the hearing aid directly in the ear canal of the patient, but also to understand how to adjust the gain of the hearing aid to the desired levels, comparing the curve acquired to the target. Basically, a complete REM procedure requires to acquire the curves without the hearing aid, so the unaided measurement, with the hearing aid inserted and turned off, occluded measurement, and inserted and turned on hearing aid, so the aided measurement, unaided, occluded, and aided. Okay. And this image visually summarizes what I have described, okay, since now. So, the purpose of the fitting in situ is to understand the following. How much does the patient's ear canal amplify naturally without the hearing aid, so the unaided measurements? Furthermore, how much does the insertion of a hearing aid occlude the patient's ear canal, reducing the natural amplification provided by the canal itself? And finally, how much does the hearing aid amplify sound after being inserted and switch on? Okay, so without the hearing aid, unaided measurement. With the hearing aid inserted but turned off, occluded measurement. And with the hearing aid inserted and turned on, aided measurement. I said that the signals acquired are compared with the target curves, which are curved, obtained, considering the audiogram of the patient under test. Other characteristics of the patient, such as the ear, the language, the uncomfortable loudness level, the most comfortable loudness level, and so forth. And then the technical specification of the hearing aid. So I want to underline that the target curves are curves obtained, okay, calculated by fitting rules, considering the audiogram of the patient, very important, other characteristics of the patient, and the technical specification of the hearing aid. The main purpose of the target curves is to provide an indication of the gains to be set on the hearing aid to optimize the auditory capabilities of the patient under test. Okay? So to provide an indication of the gain to be set on the hearing aid of the patient. In other words, a target amplification curve represents, I would say, the ideal listening level for the user of the hearing aid. The more the measurements align with the target curves, the more the patient benefits from the use of the hearing aid. Okay, there are several algorithms that provide an estimate of such curves in literature. Several prescriptive methods have been formulated since the first half of the last century, more or less. Then the introduction of hearing aids capable of providing nonlinear amplification made it necessary to develop algorithms capable of calculating gains depending on the input signal level. The most popular fitting rules are NAAL 1 and the second version, the second release, and DSL version number 5, which is more suitable for children. Okay, NAL, National Acoustic Laboratories. The NIL research group suggests to use the use of two non-linear methods, NAL1 and second release. Okay, what is the rationale? Overall intensity of the sounds does not exceed the one perceived by a normal hearing subject. So the aim of this first fitting rule is to maximize the intelligibility of speech. All tones perceived in the same way. The University of Western Ontario Research Group has then developed a nonlinear method as well, DSL 5.0, so desired sensation level. The rationale is to modify the intensity of sounds so that the hearing impaired person perceives them as they would be heard by a normal hearing subject. The aim, okay, of DSL is to avoid loudness discomfort, so same loudness perception of a normal hearing listener. Nowadays, the hearing aid manufacturers offer target curves based on proprietary algorithms. But I would say that the use of a generic target rule, such as NAL or DSL, is usually preferred. This not only because using a generic target rule means adopting a prescriptive method based on data published in literature, but also to facilitate the hearing care professional and the patient if they decide to change the brand and model of the hearing aid. So I strongly suggest that you should use NAL or DSL for your studies, okay? The only method which have been tested and published in literature. Okay. Before starting an in-situ measurement, it is really important to perform an otoscopy exam. In fact, the presence of earwax in the ear canal could obstruct the insertion of the probe tubes, or even occlude the probe tubes. Therefore, a preliminary otoscopic exam is necessary to identify such situations. The otoscopic examination can also provide detailed information on the anatomy of the ear canal of the patient under test. This information will be very useful for the operator during the insertion of the probe tubes. So first of all, okay, an otoscopic exam, okay, with our video otoscope Delfino. Second step, the most important in my opinion, okay, to perform the pure tone audiometry. Each fitting algorithms necessarily requires the insertion of the patient's pure tonal audiometry. So, otoscopic exam and, most of all, ETA of the patient. And then we can start the REM exam, okay? Here, in this picture, there is our REM system, which is the trumpet. A computer typically controls the REM system. Our software, for instance, is called Maestro. Hearing aid manufacturers' fitting software may also be installed on the same computer to enable measurement and adjustment to occur concurrently. Here we can see the trumpet, the REM system completely developed by my company, Inventis. The trumpet interfaces with the computer where Maestro software must be installed through the USB port. Okay, just a moment. We can continue with the preliminary operation. First of all, regarding the ambient noise, the environment where you want to perform the REM examination. The real sequence can be administered in most office environments, even in your office. The ambient noise of the environment should be at least 10 dB lower than the signal being presented. Before proceeding with the acquisition of the REM data, it is relevant to consider the ambient noise level, but it is not necessary to perform this type of test in the silent booth, okay? Just be sure that the noise level of your office is quite low. Furthermore, it is very important to perform the speaker equalization. So, as you connect the REM system, such as the trumpet, to the computer, Maestro software immediately will recognize the trumpet. The first operation Maestro requires to be performed is the speaker equalization. So the user just has to press one button and the speaker equalization starts immediately. The speaker must be equalized so that the sounds sent to the patient are emitted at the intensity set by the user, set by the hearing care professional. Every time the environmental setup of the REM device is modified, a speaker equalization must be performed by the hearing care professional. So if you want first to perform the RM acquisition in your office, but then you decide to move in another office, it is very important, okay, to perform another equalization. Okay, furthermore, several studies have also shown that the placement of the loudspeaker, okay, this is the aim, sorry, the placement of the loudspeaker relative to the patient in terms of both distance and azimuth interferes with the measurements acquired and then with the results of the RM examination. I would say that it is recommended to place the patient at a distance between, okay, 0.5 and 1 meter from the speaker, and okay, the speaker must be in front of the patient. Anyway, Maestro requires as first step to perform the speaker equalization, and so Maestro even provide how to proceed. Okay, so the user just have to read properly all these instructions, press on start button, and the equalization starts immediately. Okay. The second operation is this one, probe tube calibration. The probe tube's calibration takes into account the acoustic effects introduced by the tubes used during examination. Sorry, do you have a question?
Hi, Anna. We can't really see your screen anymore. Sorry for disrupting you.
Really? Oh, no.
Yeah.
Okay, probably now. Oh my God, it is strange. Something has happened. Probably now you should see the screen again.
Yes, perfect. Thank you so much.
I'm so sorry. I'm so sorry. Please interrupt me. Okay, if something like this happen again. I'm so sorry for all of you.
It's more than fine. Don't worry about it. Okay.
So the second operation, okay, as I said, is the probe tube calibration. Let me repeat this relevant passage. The probe tube's calibration takes into account the acoustic effects introduced by the tubes used during the examination. Therefore, in order to make the microphone and the tube probe acoustically invisible, this type of calibration is necessary. The figures, okay, you should see on my screen shows how to position the probe tube in order to proceed with the calibration. The probe tube tip, okay, must be placed as close as possible to the reference microphone of the probe headset. Okay, it is very important. Anyway, don't worry, because Maestro, okay, helps the user, okay, tells the user step by step how to proceed. So after finishing the equalization procedure, immediately this probe's calibration screen appears on the Maestro screen, and so the user keeps in mind that it is very important to perform the probe tube calibration. After it is in place, okay, then place the bow in front of the loudspeaker at an approximate distance of 1 meter, more or less. I wanted to show you, just a moment. Okay, this is the placement anyway. Okay. Important to underline that the probe tube must be calibrated every time they are changed. It is very important. Every time the test is conducted on a new patient, the system will prompt the user to run the calibration of the tubes before the first measurement is made. Regarding the placement of the probe tube, as you can see in the picture on the screen, typically the silicone tube is positioned so that the distance between the tip and the eardrum is no more than 3 up to 5 millimeters. The presence of a ruler in the bow and the probe tube black ring can be very helpful. An example of a correct insertion of the probe tube, okay, in the ear canal is shown in this picture. And that's me, okay, just to underline even this aspect. Okay, the black one is a reference, is a population curve, okay. This one, the violet one, suggests the hearing care professional that the silicone tube has been properly positioned inside the ear canal. Anyway, we will investigate this picture in a few minutes. Okay. Perfect. How to acquire? We can continue. So, real ear measurement acquired on the patient. The REM systems allows the operator to acquire many types of measurement defined in ANSI and ESC standard and classified in response measurement or gain measurement. I didn't tell you, but it is quite banal. U stands for unaided, O for occluded, A for aided, and I stand for insertion, real ear insertion measurement. Okay, so the hearing care professional can acquire response or gain, can perform, sorry, a response or gain measurement. Response measurement, such as REAR, rare, rare, reur, REUR, so real ear occluded response, real ear occluded, aided response, real ear unaided response, and so forth. Response measurements are acquired by the probe microphone near the eardrum in response to an acoustic signal emitted by the trumpet or the REM system loudspeaker. Okay, so response measurements are acquired by the microphone which is closed to the eardrum, and that's it. Gain measurement, such as the real ear unaided gain, real ear occluded gain, insertion gain, aided gain, have differential measurements calculated by subtracting the signal measured by the reference microphone, which is close to the pinna, from the signal acquired with the probe microphone. Okay, so the sound before the amplification and the sound after the amplification. The choice to use a response or gain measurement provides a different way to quantify the signal amplification in the ear canal of the patient. Anyway, it is up to the hearing care professional, okay, to choose how to proceed, to choose if to perform or a gain measurement. In my opinion, gain measurement is better than the response measurement, because gain measurement are differential measurement. So you know the value of the sound acquired close to the pinna and the value of the sound acquired closer to the eardrum. Okay. Anyway, it is up to you, definitely. Okay, Maestro software, the software which control our Inventis trumpet, our REM systems, allows to perform the following tests. Measurement with a hearing aid, okay? Sorry, without the hearing aid, with the hearing aid turn off, with the hearing aid turn on, and insertion measurement. Furthermore, okay, the standards required to get even the maximum power output, okay? Advanced mode and live speech mode are counseling tools we have developed and added to Maestro considering our customers' needs, okay? Anyway, standard, unaided, occluded, aided, maximum power output, and then we will also check quickly even the advanced, but most of all the live speech mode. Okay. Perfect. First of all, unaided measurement. Okay. Can you see my screen? Everything is clear? Everybody can see my screen? Yvette?
Yes, yes, everything is quite clear. We're having quite bad connection though, but I'm very happy that we are recording this so that we can have the recording.
Yes, okay.
Yes, everything is clear so far. Thank you so much, Anna.
Okay, anyway, my screen, you can share my screen. You can see it properly, right? Okay. So, unaided measurement. Once the probe tube has been inserted into the ear canal properly, it is possible to proceed with the REM examination by acquiring the unaided measurement. This measurement is accomplished without any hearing aid to assess the amplification of the patient's canal resonance. Okay, so to check the natural amplification of the ear canal. The acquisition of a real ear unaided gain curve, although recommended, is not strictly necessary, since each fitting rule implements its own predicted average, then can be used for following assessments. The use of a predicted average, real ear occluded gain, can, however, lead to inaccurate results, especially if the patient's ear canal is not of average length, diameter, or size. Anyway, to acquire a real ear unaided gain curve, okay, the user can choose whether to use a white noise or a pink noise that will be sent by the speaker at a predetermined intensity. The choice to display, together with the measurement, the predicted average real ear occluded gain, can be a useful reference, I would say, to verify in real time if the signal being acquired is reliable. Otherwise, the probe tube may not be inserted properly. In this situation, it is possible to change the placement of the probe tube until the two curves are compatible. Okay, so the camera curve is the standard, the population curve, which always appears on the screen. The violet one is the curve acquired for the patient under test, patient who is not wearing the hearing aid. Okay? That violet curve represents the value of the sounds acquired at the eardrum by the probe microphone. Okay? It is important sometimes to compare the camera curve, which is the standard one, with the violet curve acquired in order to be sure that the user have inserted properly the silicone tube into the ear canal. Okay, hope so. So, an aided measurement helps to understand if the probe tube has been well inserted in the ear canal, comparing to the other one acquired with the predicted average. Furthermore, real ear occluded gain is used as input measure to obtain a more precise target curve. Remembering to select real ear occluded gain measured in the target setting in Maestro software. Okay. I think that someone opens his PC. Okay, now it should be right again. Okay. Inserted and turned off. So occluded measurement. The hearing care professional then inserts the hearing aid into the patient ear canal. Pay attention to maximizing the possible displacement of the probe tube. In occluded mode, occlusion response, real ear occluded response, or occluded gain, real ear occluded gain, REOG, measurement can be taken with the hearing aid inserted but turned off in order to establish the level of occlusion introduced by the physical presence of the hearing aid. Typically, in the case of an occlusive hearing aid, it is expected a gain reduction compared to the REUG curve in the frequency range corresponding to the natural resonance region of the ear canal. Conversely, if the patient is wearing a non-occlusive hearing aid, the gain loss respect to the REUG curve will be considerably lower. Okay, so occluded measurements instead help to understand if an open fitting device is really open. Okay, so if the REUG looks like the REUG measured previously, or vice versa, to understand if a completely occlusive or semi-occlusive device with band of different diameters works well and at what frequencies they work well. For example, you can evaluate at what frequencies this vent goes to improve the natural amplification of the ear canal or to reduce it, and therefore understand if it already meets the patient need or if it goes to impede the gain of the hearing aid. Perfect. Then the user can continue with the acquisition of the aided measurement. In aided mode, aided response or aided gain measurements are acquired with the hearing aid inserted and switched on. The signals acquired show the intensity of the sound pressure at the eardrum after being amplified by the ear canal and the hearing aid. So, amplification provided by the ear canal and, this time, even by the hearing aid. Even here, the hearing care professional selects the type and intensity of the signals the speaker will generate. Typically, speech-shaped signal such as the ICRA, International Collegium of Rehabilitative Audiology, or ISTS, International Speech Test Signal, are used. So, ICRA or ISTS. The frequency spectrum of these signals simulates the real speech. Moreover, in order to reproduce different credible situations, different measurements at different intensity should be taken. Okay, this graph, the graph, represents a REAG, real ear aided gain, the continuous curve you can see in the picture, which is associated with the corresponding target curve calculated by the fitting rule, dash curve selected. The purpose of this type of measurement is to assess that the acquired curve deviates as little as possible from the previously selected target curve. So, the fitting rule calculated the target curve. The hearing care professional has acquired the REAG curve, which is the curve, okay, acquired from the patient. It is very important, okay, that the REAG, okay, can assume a shape as similar as possible the shape of the target curve, okay? The shape must be very similar. The aided curves described so far represent the gain contribution provided. If the operator was interested in quantifying the contribution provided by the hearing aid only, simply select the open insertion, okay? And the real ear insertion gain measurement will be acquired. We will see that it is pretty used to the usage, the usability of Maestro software is very high. Maestro is a very user-friendly, has a very user-friendly interface. So if the user wants to acquire a real ear insertion gain, it is just necessary to push a button, okay? And that's it, to press one button. If you want to acquire a real ear occluded gain, another button, it is very easy to use, okay? We will see it later. Very important. Okay, so the introduction of open fitting has allowed a great step forward in solving the problems related to comfort and satisfaction. This system allows almost complete communication between the ear outside and inside the ear canal. Okay, you know, the open hearing aid. So I would say that it is suitable for patients suffering high frequency hearing loss, poor amplification at low frequencies, okay, I would say. Instead of the tubing and the ear mold that occludes the ear, a fine plastic tube is used that ends with a soft cap that is inserted into the ear, okay? You can see this picture, the picture on the screen. Be careful of acoustic feedback. Indeed, it can happen that part of the sound produced by the hearing aid in the ear canal escapes and returns as input to the hearing aid itself, being amplified again. If you are testing an open hearing aid, please select the open fitting option in Maestro software. Very easy. Maximum power output. A properly functioning hearing aid should not only be able to amplify the external signals, but it must be set so that the amplification provided is not dangerous or annoying for the patient. In MPO, so maximum power output mode, the instrument can provide a response measurement to check that the output from the hearing aid does not exceed the uncomfortable loudness level, UCL, identified for the patient, even when a signal of high intensity, typically 85 dB SPL, is generated. So, this continuous curve is the curve the NPO acquired for the patient. The dash curve is the one provided by the fitting rule. So that patient who wears that hearing aid, the patient who has that pure tone audiometry, and whose hearing aid has that specific characteristics, must have this maximum power output, okay, which does not exceed the dash line. Okay, live speech. It could be particularly useful for the patient and for the others to observe how the use of a hearing aid can improve the patient audition. For this purpose, the live mode within Maestro allows the hearing care professional to obtain this measurement. Okay, this test mode has a counseling purpose. It allows performing a comparison between the response measured with the hearing aid inserted and active with the estimated response without the hearing aid. Okay, so the patient wears the hearing aid and at the hearing aid is turned on. At the same time, the software can acquire two different measurements, okay? A curve which represents the listening level of the patient without the hearing aid and how the patient may hear the sound with the hearing aid turned on, okay? So you can compare the two curves here on this graph. The red one is the pure tone audiometry, okay? So the PTA. This continuous green curve is the level of the sound close to the eardrum of the patient with the hearing aid inserted and turned on. The dashed line represents how the patient, okay, can hear the sound without the hearing aid, okay? Perfect. So the combined visualization of the two curves, level of sound heard with continuous curve and without dash curve, the hearing aid, and the subject's angiogram allows one to appreciate immediately and intuitively the benefit the adoption of a hearing aid can provide. Okay, the gray region on the screen represents the speech banana modified according to the audiogram of the subject being examined. Since the perceivable sounds are those that exceed the red curve, which corresponds to the patient's pure tone audiometry, the advantages a hearing aid could provide are immediately noticeable. Very important, in addition to the speech-like signal available, such as the ISTS or ICRA, it is possible to use the voice of either the operator or the patient relatives as a signal, okay? This creates an even more comfortable and familiar situation in order to let both the patient and their relatives appreciate the advantages a hearing aid could provide, okay? So, live speech module, counseling purpose, very important to underline. Okay, when an aided NPO or a live measurement is being performed, it it is possible to take advantage of the software option called on top mode. Okay, you can see the on top here. Okay, the gray part of the image on the screen. On top mode. This option, the on top mode option, allows the operator to work simultaneously with the software of the hearing aid, displaying in real time as the gain adjustment can be reflected in the curve acquired at the REM system's microphone. Using the on-top mode, the Maestro window is displayed in a smaller format and always in foreground. For instance, the picture shows an example of how to use the on-top option. The operator who is performing an REM examination can adjust the gains of the hearing aid from the software provided by the hearing aid, okay, the hearing aid company, and assess at once if the measurement acquired, in the example 8 dB SPL REAG, moves close or away from the corresponding target curve. So it is a very important feature because you can use two different software at the same time. You can use the hearing aid software in order to adjust the gain. And at the same time, you can use a Maestro and check if the curves acquired are close or not to the target curve provided by the fitting rule. Okay, I wanted to ask you if you have some question, because now I want to quickly introduce the trumpet. Jivette, Jayesh?
Hi, does anyone have any questions so far? You guys can either unmute yourselves and ask the questions. This is an open area to be asking questions. Any questions so far? Are we all happy?
Anyway, at the end of the presentation, I can forward the presentation itself. And so if all of you come up with a specific question, please email me whenever you need.
Perfect. Thank you, Anna.
Completely available to answer with great pleasure all your questions. Very important for us. Even your suggestions. If you come up with brilliant idea, okay, in order to improve our system, which I'm going to describe, please just let me know. I will be more than glad to answer all your questions. Absolutely.
Thank you. Thank you very much, Anna.
Okay, so in the pictures, okay, and from this camera, there is our trumpet, our real ear measurement system. Okay, in my opinion, it is fantastic. Okay, and very easy to use because the software is very easy to use. The acquisition of in-situ measurements so represent the most efficient method to ensure the patient could achieve the best fitting. In fact, we can think of having adjusted properly the gains of a hearing aid only when the quality of the sound reproduced by the hearing aid itself is optimized according to the patient's needs and preferences. Such a balance between audibility and optimization of the stimuli quality can only be obtained by measuring the sound produced by the hearing aid directly in the ear of the patient who wears the device. Okay, so it is very important to use a real ear measurement systems to be sure that, okay, the patient is comfortable, feels comfortable with the hearing aid she wears. Absolutely. Okay. The execution of a REM examination necessarily involves a initial investment of time, I would say, for the operator. However, this investment results in a subsequent significant reduction of appointments for adjusting the gains of the hearing aid. And this is the trumpet. The trumpet, so, is our advanced and easy to use real ear measurement system capable of performing quick and accurate, most of all, in situ measures, thanks to its small, lightweight probes and its built-in amplified speaker. But it is very important to underline that trumpet also incorporates a diagnostic audiometer for carrying out ear, bone, and speech audiometry exam. Okay? So if you want to test, to perform the fitting in situ of a patient, you can with the trumpet, but if you want at the same time to use the trumpet, for instance, to perform a speech exam in pre-field at your patient's place, you can always with the trumpet. So with the trumpet, it is possible to perform pure tone audiometry, speech audiometry, okay, in air conduction, bone conduction, but also in free field using the built-in speaker. Sorry. Okay, so only one hardware, but 3 models. Trumpet for in situ measurement, trumpet as a diagnostic audiometer, trumpet for in situ measurement and diagnostic audiometer at the same time. If you want to have a trumpet only as a RAM module, you can. If you want to add in the future the possibility to perform even the PTA and speech exam, you can do it just enabling a simple license. Okay, so this is the trumpet and this is its built-in speaker, relevant for performing REM test, but using the speaker, you can even perform pure tone audiometry and speech audiometry in free field. Extremely small and light probe. Each probe contains the reference microphone and the probe microphone, okay, as it is shown in the pictures. So probe microphone with the silicone tube, which acquires the sound close to the eardrum. The reference microphone close to the pinna acquires the sound, okay, before the amplification provided by the ear canal and the hearing aid, if the patient under test is wearing the hearing aid. Okay. With trumpet, there is also the option of a kit with built-in speaker and a 2cc coupler, which will allow LCD measure to be taken from non-collaborative patients without the need for a hearing instrument test box. What does it mean? To be honest, sometimes a child can't. It is very noisy for a child to have the silicone tube inside his ear canal for a long time. So, if you want, you can use a trumpet with the RECD box, which is this metal box which can be connected on the trumpet real panel. We provided it with the 2cc coupler, the RCD box with the trumpet. Okay, they both allow the user to perform fit in, okay, for uncollaborative patients, okay, such as children, pupils in general. Regarding trumpet as an audiometer, so in the audiometer mode, trumpet can perform ear, bone, pre-filled and speech audiometry exam. Hudson Westlake automated audiometry, quick scene, and a master hearing aid. Connect the trumpet to the USB port of your Windows computer and you are ready to go. No driver, no additional cable required. You can control trumpet through the amazingly user-friendly Maestro software interface and, if need to be, transfer the data directly to NOAA. Okay, so insert earphone for air conduction test. Patient response switch. Bone transducer in order to perform audiometric exam in bone conduction. Then DD45 headset in order to perform air conduction test, okay, with the supraaural headphone. Talkback, okay, for the communication between the patient and the doctor. Talkover for the communication between the doctor and the patient who can be inside the silent booth, and the speaker. Perfect. On YouTube, we have uploaded a list of videos you can use to get essential information on the Inventis trumpet. Okay, so if you want, you can Google, okay, just fill in the word YouTube Inventis trumpet, and the video series that we have recorded will appear immediately. Enjoy the video. Okay, so now I would say I would like to show you Maestro software and how to perform an exam, okay, using our Inventis trumpet. Okay. This is the trumpet. You can see trumpet. Elisa is with me one more time. Okay. So this is the trumpet. Okay. The probe, the left one and the right one, with the silicone tube inserted. Okay. On the screen, you can see Maestro software. I have connected the trumpet to the computer using the USB cable. Okay, it is quite banal, and immediately Maestro has recognized the trumpet. REM. Perfect. So, as I told you during this presentation, I told you that the first operation, okay, it is necessary to perform is the speaker equalization. So Maestro, okay, helps the user and tells the user that it is important to perform the equalization. The current system equalization is not accurate for this situation. Do you want to run a new equalization? Recommended. Yes, sure, I want. So now I would like to, thank you very much, Elisa, to wear the tube. Sorry. Can you see me? I hope so. And thank you guys. And I'm in front of the speaker. Okay. Perfect. Trumpet is connected to the computer. So now I just have to say yes and press on the start button. Maestro provides instruction about how to put the data and patient in front of us. Okay, so ok, devo cliccare su start. Che non mi va. Ecco, perfetto. equalization successfully completed. Okay. Okay. Before proceeding, you should calibrate the probe microphone. So I wanted to underline that the Maestro is very user-friendly because the Maestro helps the user, okay? And underline step by step what the user has to do in order to perform the perfect fitting. So yes, definitely yes. So please, Elisa.
I'm putting the probes in order to have the probe microphone and the reference microphone very close, both on the left and on the right. Okay.
Okay. Now, okay. Acted on the right side, the calibration frame. We can try one more time. Okay, I'm sorry for this little issue. The problem is that most probably I have choose my trumpet, which is not perfectly up to date. Anyway, it is very important to perform this kind of operation. Just press start and check that a continuous line, okay, appears, okay, in the middle of these two, the lower one and the upper one. Okay. Perfect. Okay. So, characteristics of the stimulus. Okay, single side or bilateral. Visualization option, okay, and test modality. Unaided, occluded, aided, maximum power output, advanced, and live speed. Okay, if you want to perform, for instance, the first exam, just press on unaided. Okay, I wanted to test the left ear, and so I pressed on left. Okay, perfect. Show single side. Response. Okay, perfect. Okay, now Elisa will insert the silicone tube inside my ear canal. It is not easy because we are not audiologists as you are. Okay. Now I just have to press on play. The speaker delivers the stimulus, a pink noise at 70 dB SPL. Now I'm talking to you. The speakers, sorry, the microphones are acquiring even my voice. And so the violet curve is moving on the screen. Now Elisa, okay, should move the silicone tube and adjust its position inside my ear canal because more or less the violet curve and the population curve must match. Okay, more or less. And this is the regular curve. Okay, the result is not perfect, but because we are not audiologists, okay, and the environment is quite noisy, I would say. Occluded. Left ear, okay, even this time, On the screen, there is the REUG acquired previously. Okay, perfect. Even this time, sorry, in this time I should wear the hearing aid, and the hearing aid, which is this one, okay, must be turned off, is turned off, because the purpose of the occluded measurement is to analyze the natural how much the presence of a hearing aid inside the ear canal can occlude the sound which crosses through the canal itself. Yes. Okay. Sorry, but we are only two, and it is not easy to move the camera in order to focus on me, on Elisa, and on the system. So I'm sorry. I would prefer to focus on Maestro software. Okay. So just a moment, I'm waiting for Elisa. Anyway, this is the occluded. This is the aided mode. Okay, it is important to consider the pure tone audiometry of the patient. Okay, this is the maximum power output. The advanced mode. Okay, the advanced mode takes into consideration a higher range of frequency, up to 12 kHz. And this is the live speech. In the live speech mode, I can select as input the sound, not a specific speech sound, but the voice, your voice, the voice of the patient, the voice of the doctor, the voice of the relatives, and so on, as you prefer. Okay. From here, you can select the fitting rule. Okay. Inside Maestro, okay, we have added NAL, first and second version, and the DSL. Okay, Elisa is here one more time. Okay. Anyway, it is not important. Okay. Sorry, guys. I'm not an impaired patient. I'm not a patient, and so I just wanted to show you quickly how Maestro works. Don't worry, Lisa. Don't worry. Okay, so we can try one more time. So
the probe tube,
yes. Anyway, I can show the audience only how Maestro works, Lisa. So don't worry. You can.
Okay.
You can go if you prefer. Okay, as we are not audiologists, it is not easy for us to put the hearing aid inside my ear, but this is the operation that must be done in order to perform occluded and aided measurement.
So keep the probe tube fixed. I just have two hands, so I cannot keep the probe tube with one hand. With the other hand, you move the hearing aid in order to insert it in the patient ear, as if she was wearing it.
Okay. Okay. The hearing aid is turned off. Okay, important. It is an open hearing aid. So I can record the sound. Adesso vediamo. Non so come fare. Okay, so I'm sorry because we don't have the perfect conditions in order to conduct the perfect fitting, because I'm not an impaired patient. We are not audiologists, and so, but anyway, I just wanted to provide you some tips about how to use a Maestro software. Okay, I want you to get how easy it is to use a Maestro software. Then we have, okay, to get the aided measurement. So first of all, it is very important to select, okay, the PTA of the patient. Non-PTA. Just a moment, I want to select a simple PTA, so I can select the patient. Save changes. Underline. Okay. PTA, because trumpet is even an audiometer. Ok? Ecco. Faccio una posizione così, non quella. Ok, aided. So, the audiologist or the hearing care professional must acquire the aided measurement, so without the hearing aid, in order to get the natural amplification of the ear canal. The occluded one with the hearing aid inserted and turned off, okay? The first curve and the second one match if the patient is wearing an open hearing aid, surely. Then we want to acquire an aided measurement, okay? So to get the amplification at the eardrum, amplification provided by the ear canal itself and the hearing aid. Perfect. So in this moment on the screen, okay, there are shown the UCL of the patient, the pure tone audiometry, and this is the target curve. As I showed you before, from here I can select the fitting rule. For instance, NAAL second release. Settings. Now you have to fill in some information regarding the patient, information regarding the pure tone audiometry acquired, and information regarding the hearing aid. For instance, I'm an experienced user or I'm a new user. First fit in. Language type, tonal. The Chinese is a tonal language, but my language, your language are non-tonal languages. Audiological input, okay? Did you use the bone vibrator in order to acquire the pure tone audiometry? So did you perform the PTA not only in air conduction, but also in bone conduction? Yes or no? Just press on the correct choice, okay? Press on what you did. No RCD. Okay, real ear occluded gain. Unaided gain. Did you acquired? Yes, I did. Or did you use the population curve? If is the latter, just press on predicted. Hearing aid. Fill in the information about the hearing aid. Is it a bilateral or a unilateral? Okay. Is it a BTA completely in the canal? In the canal, just select the type, okay, of hearing aid. Select the number of channel, for instance, 18, even more, okay. Select the venting, select the tubing, and so on. Just select all the information for the input and for the hearing aid. Then press on save, and that's it. Okay. Predicted. Okay. Now I'm on the aided UCL, PTA, and this is the target curve calculated by the fitting rule. This is the target curve for the lowest sound, for the medium one, and for the highest sound. Okay, I just wanted to underline that these data which appear on the screen are not realistic because I'm not an impaired patient. Okay, and so I just wanted to tell you how Maestro works. Okay. Perfect. Now, on top mode, okay, I can open the software. I can open the software of the hearing aid, okay, and I can then compare the curve acquired with the target one. Okay, so now I'm not wearing an hearing aid, but the hearing aid, okay, should inside sorry, I know. It is just a fake simulation. The hearing aid should be inside my ear canal and should be turned on, okay? And so it is very important to compare the continuous line with the dash one. When the shape of the two curves match, you just have to adjust the gain, okay, from the software of the hearing aid. Just proceed with the acquisition. Okay, and that's it. And then, so you have to perform this test, okay, even always using a speech signal for the medium sound and the highest one, okay. It is very important, as I underlined before, to use the on-top mode, because with the on-top mode, you can use at the same time two different software. Maestro software, in order to check the differences between the curve acquired for the patient under test and the target one. And the software of the hearing aid, because from that software, you can adjust the gain, okay? Maximum power output, as I told you before, this is the maximum power output provided by the fitting rule. Even this time, the speaker will deliver a nice sound of 85 dB SPL. It is very important that the curve acquired for the patient under test does not exceed the dash curve on the screen. Okay, even this time the patient must wear the hearing aid and the hearing aid is turned on. Advanced setting, as I told you before, okay, allows you to have a more focused vision, okay, of what it is happening, because the frequencies range is higher, up to 12 kilohertz. And in my opinion, one of the most important features we have implemented is the live speech. Because with the live speech module is a counseling tool, okay? And the patient wears the hearing aid is turned on, and at the same time you can acquire a couple, two curves. How the patient can hear the sound with the hearing aid, and how the patient can hear the sound without the hearing aid. For instance, if I press on the play button, okay, can you see the two curves? Okay, the continuous one is the aided with the hearing aid, and the dash one is the unaided, okay? And so from the screen, the patient, but most of all, I would say the relative, can understand why it is important to purchase the hearing aid. If you want, this time you can use your voice, or if you prefer, you can even use environmental sound, such as the mocha pot, okay, the kids, the doorbell, for instance, the mocha pot. Can you hear? Because the patient under test is an impaired, okay? And so, in my opinion, if he can understand that using the hearing aid, he can even hear sound provided by the most common, the most familiar sound, he can feel, in my opinion, more comfortable, for sure. Okay. And so this is, I'm so sorry for the issue faced from the beginning, but as I told you before, I just want you to have an idea of how easy it is to use Maestro software. Just connect the trumpet to the computer, Maestro will recognize it immediately, and you, your hearing care professional, just have to start from the unaided measurement, okay, perform the occluded, the aided, or if you want, just the live speech, in order to convince the patient that it is very important for him to buy a hearing aid. Okay. And more or less, I would say that that's it. Do you have some questions?
Any questions, anyone? I'm happy. I feel like it was clear, it was concise. Mrs. Singh, any questions?
About software, about
Guys, do you all have any questions at all? Any comments you'd like to add? Anything more specifically, what we really need from you all is for the balance of 2020, aspects and ideas in terms of what you'd like from Inventis. So different aspects of audiology, because this is an audiological company. So if you can pop me an email, or even, you know, write through to me via the website, it comes directly through to me on my WhatsApp. Give me guidance in terms of what is it that you feel for professional development we actually do need in South Africa. I do see that we have some of our friends from Botswana here, as well as Zimbabwe. So please, if there's anything, can I say, for Africa, I would really appreciate it. Otherwise, it's just going to be my team of audiologists here that we are sitting and discussing. Like, I do know I've received some emails that have come through, and they've said, can you please bring us something on auditory processing? I said, that's fine. Then there was a speech therapist that wrote and said, can you do something on learning disability, but the link to the fact that it's linked to the food. So we're trying to get in a dietitian in that's going to be speaking about all the different aspects and, you know, the food colorants, etc. So audiologists, you would see this, you know that AMHT is so pro about professional development. So even though it may not be pure audiology, and I do know there's an OT that's here as well as 2 ENTs, join in, because it's going to be something that's interesting, because we are all seeing patients, you know, that may have some dizziness or tinnitus, or they have learning disabilities, ADD. So we're really trying to ensure that we cover, you know, all aspects of rehab. Now, something that I need to tell you, and you will see that it's released tomorrow. So through Inventis, as Ricardo indicated, that Inventis acquired Synapses. So Inventis is in Italy. They're in Venice. It's a lovely little town, and they have acquired Synapses. So Synapses is a French company that's now owned by Inventis. So on the 29th of June, you will see this is going to go nationwide tomorrow. We are releasing this. It's going to be that Inventis is basically inviting all countries of the world. So there might actually be like, God, 60, 70 countries. And I really want Africa. Why I say Africa is because it's not only South Africa that AMHT looks after, but we want, there is a competition that they're running. And this competition means that a VNG system with VDT, etc., the full vestibular lab is up for grabs. So I'm hoping that it comes through AMHT to South Africa. So what we're actually doing is, and I'm confident we're actually going to win it, okay? So with this, the conditions are to be eligible to win this. It's a 5-year VNG full vestibular system that we are prepared through AMHT, a government institute or special education. But the only conditions are free of charge. We're not charging you anything, but we're requesting that whatever research whatever testing you're doing with your patients, that if we can use that research for free CPD activation. So whatever you are doing, this is not a sales panel, but I'm saying you're going to get an equipment that is so sophisticated in your practice up to 5 years. Even if you're in government, we're going to leave it there, but conditions allow us to get research so that we develop professional development more. We're also looking at the fact that you must be prepared to travel with an AMHT rep that will go up to UHA, which is the International Congress in Germany. This year's been cancelled, but definitely next year it's on. Then you must be prepared to come up with us when we take
Audio.
Okay, can you hear me now? Okay, so
Now,
you're going
yes.
to be receiving a total of 10 points for the 29th of June. And this is something that we're really looking forward to. It's going to be on the 29th of June, and it's going to be hosted by Inventis themselves. But the competition is going to be for Africa, okay? I'm hoping that Africa wins, as I told you, and all you have to do is do the pre-registrations, please. Make sure that you send it through so that we can get your CPD activations accredited as soon as, you know, these the webinar is actually accredited, as well as the articles will come through. So it's 10 CPD points on the 29th at 9 to 10:30. Yvette and Anna will give you a little bit of information about the title of the program and then the ENT that is actually hosting it. Now, whilst Inventis is running it over 2 days, we at AMHT board took a decision that we want Africa, South Africa, Botswana, Kenya, exactly where our partners are. We want you all to join in on the 29th. We want to go in with a big team so that we definitely bring in that system to Africa. As I told you, that you will have this system, which is really sophisticated, up to 5 years. If you know absolutely nothing on vestibular, our vestibular team, and now we have a mechanical technician that is part of our team. So he's going to be able, as well as the audiologist, in terms of training you guys. So you'll be trained thorough. As I said, you need to have a passport, please, because you'll either go with us through to Italy or to France. Definitely German, UHA next year. And please, from tomorrow, please, you will see all the this webinar details. It's going to be on our website. It's going to be sent through to bulk emails. Activate it immediately. We really, but it's not only about winning the VNG and the VHIT system. It's about learning. It's about allowing us to grow professional development in South Africa. We have no issues whether it's going to be placed in a government institute, special school, or private practice, as long as we are all benefiting from the research that actually comes out of that. The only thing what I would request from you guys is there's going to be a poll that's going to go out. We just need an indication that when we remember, AMHT is committed to free CPD since 2007. So what we actually want is, we're looking at the first week of each month, you will receive the newsletter. In the newsletter, we've got a technical audiologist, Yvette Belankulu, who overlooks and gets information like from Anna, like from Michael from Neurosoft, etc. So it's going to be technical advancements that we can all learn from. So the newsletter goes out in the first week, and it's all about, there's quizzes, there's competitions, there's updates on the ethics, etc. On the second week, there's always a live draw. Like the one that is going up now, there's a 4D ear, as well as an otoscope that's actually up, that typically the competitions go through on the second week of the month. And on the third week of the month, we always host a webinar. It's something to do with professional development, it's clinical applications, etc. So tomorrow, please complete that poll. Give us an idea. Do you like the webinar to be on a weekday? Would it be more comfortable if it's on a Saturday at home? You know, you grab your cup of coffee and you're part of this. Is a Sunday afternoon good? Because we are assuming that, you know, a weekday is going to be good, but some of the feedback, you know, we're getting is people are saying, but would you not consider this? Because it's something we do monthly. It's not just a once-off thing. We want to grow the profession. So please complete that that poll as well. And I'm going to ask Anna and Yvette to please explain about the topic on the 29th. And remember, we're going in as a full force, and you need, okay, you need to put your details on and state whether you are from South Africa, whether you're Zimbabwe, Kenyan, etc. Because that's how Ricardo and his team are going to know that that system needs to come to Africa. Yvette, Anna?
Yes, Anna, would you like to explain more about your VHIT system? I have done a bit of research about the VHIT system. I know that it's non-invasive, there's no goggles attached and things like that, so it is exciting. I myself am very excited to actually be to listen in on your presentation next week. Is there anything that you'd like? You can't hear me.
No.
Such rainy weather today. It's very bad. Can you hear me, Anna?
No.
Okay, I don't think work with us, but I can't wait for everyone to actually come and join us for next week's webinar. We will be sending through, as Mrs. Singh has said, we're sending through the notifications and so forth. We want you guys to register to join in, and as Mrs. Singh has said, all you have to do is state where you're green, but it is right here. Please join in on the 29th of June, which is this month, at 9 o'clock. We will see you then, and we are super excited. Thank you so much once again for joining in. I hope everyone put in the chat section so that you can receive the space for the full 2 hours who will be receiving these CPD points. Thank you very much, Anna.
I don't know if Jayesh or Jivette, because the line is very disturbed now. You're not sure what you are saying.
Yes. Can you hear me?
Yes. So the signal is not clear, and so the line is interrupted. So I wanted to conclude saying that it has been a pleasure for me to perform this training. I'm so sorry for the issue with the software, but it does not depend on Inventis, but on my computer. I hope that everything is clear. I'm going to forward to Yvette my presentation, and please, if you need some clarification, contact Yvette and give me whenever you need. I'm completely available for all of you.
Thank you very much, Anna. Really, really appreciate it.
Okay, let me see. Can you guys? Can you guys hear me? Is it clearer? Because with that, it's breaking quite badly. Can you guys hear me? Okay. All right. So all the in tomorrow, it's a vestibular workshop. It's going to be presented by Dr. Enrico Armato. Thank you so much for joining, guys. It was awesome that you were here, and see you soon. Please be safe. Please be warm. Thank you so much for joining.
Thank you.
Thank you. Bye.